Hello YouTube viewers, welcome to my channel Science to Technology. In today's show, Rocket Monday, we're going to talk about Small Satellite Launch Vehicle or SSLV Demo 1. So let's dive right into it. Now what exactly we are talking about? We are talking about a demo launch. Now why this is a big deal? Well, think of it this way. India has a big satellite launcher that is known as GSLV Mark III. It's for big boys. When we have medium-sized system that is called PSLV that created right now the second world record of 100 plus satellite launches. SpaceX overtook it. So before that, India was the top one using PSLV. Now PSLV medium class system. However, SSLV was specifically designed for taking care of small satellite. So it's a dedicated system where you do not have to do ride sharing. Now it was launched on 7 August 2022, 3:48 Universal Time Coordinate, 9:18 a.m. morning, early morning basically, Indian Standard Time. Location Satish, Dhawan Space Center, and it had two major satellites, only two. EOS O2 Earth Observation Satellite, specifically designed for infrared and optical systems, and then you had Azad satellite. Azad simply means independence, and it had radio transponder for ham radio. Many times ham radios can utilize satellites, specifically if government launches some satellites. It's a goodwill kind of mission kind of scenario where sometimes if they have large observation satellite, they will just put a ham transponder on it. It's been done, like almost all association does that, be it NASA, be it ESA, be it even ISRO. So these were the two satellites that were put on top of it. Now, what's the design of this new design vehicle? Well, it has three-stage solid rocket motor. Now, three-stage, first of them is very big, this boy, big boy. That is a 2,600 kilonewton boy. Then you have 7.7 ton, which is second stage that goes on top of it. That is 235 kilonewton. And then there is third stage that is 4.5 ton. I could not find the kilonewton figure of that. Now, all these are solid boosters. Now they do have gimbaling system, but gimbals are kind of rudimentary. Again, liquid will always have much superior control over its directionality. So if you are using all the way through solid system, you may need some love at the upper stages. So it has the final deployer, that is liquid fed velocity trimming module, meaning boosters are running kind of overburn, whereas like it's going to put some extra on it, and then the velocity trimming module is going to fine tune it. Basically, it has too much energy. It's like, okay, let me align it. So basically, orbit insertion and circularization will be done by the last module. Now it has carbon fiber filament wound case because grain structure cannot be changed too much. Again, chemistry limits it. But casing, if you are very poor, you can use stainless steel. If you have a bit of money, you can use lithium aluminum alloy. If you have boatload of money, you can use titanium. If you have even more money, you can use carbon fiber wounding system. Now again, people are suggesting the prices are coming down because it's becoming mass production, maybe. And the grand total weight is a big boy. It is 120 tons, seriously heavy stuff. 2-meter diameter, so it's a chunky boy, and 34 meters height. It's huge, as in like most, even though it says a small satellite, but think of this, these are people and this is just stage one. So it's a tall boy, like really tall boy. So what was the result? It was launched, everything worked perfectly, all the data and velocity, all the things were working perfectly. So all solid stages worked nominally, meaning no hoo-ha, no chingalala, everything worked as it's supposed to. However, the moment the final stage was deployed, meaning velocity trimming module, it failed. Now it did fire its engine, but it shut off very quickly. Now at this point in time, this is not too old enough, and when I'm making this video, all my data analysis suggests, early guess, be mindful, I hope there is more data available, but early guess is that one sensor malfunctioned in that system. Now again, all the systems are designed in such a way that they have safe failover, meaning this is failed, no problem, let's switch over to something. That somehow failed, that got blocked, and consequence of that, the main engine, basically the trimming engine, did not start properly. Well, it's just like poof, it needed like a constant burn for a few seconds. So delta V was not as it's supposed to be, and it crashed into the atmosphere. So nothing out of the ordinary, realistically speaking. It's a flat out normal for first of a rocket to go. This is normal, it's like expected kind of scenario. Again, many people will freak out if you launch it first time and it works. It's like, think of it this way, like what if Starship actually landed on the first try? People will like, dude, that does not work. But again, it went boom. So it's normal, nothing out of the ordinary. And my guess, again, this is my gut feeling, I think it's not hardware fault. I think it's most of a software glitch kind of scenario. So that's the result of it. So that's why satellites are lost at this point in time. So what about cost effectiveness? Now this is the critical aspect. At this point in time, nations and global market are growing specifically in small sats, meaning satellites that are generally half a ton or maybe even 1 ton small. Again, the ratings are not very clear cut. Sometimes people say it's only CubeSats, but again, CubeSat is a designation. So you get the point. Basically, people are making small. Now, why? Well, back in the days, we used to have giant ass geostationary satellite. They were the backbone. Again, they were huge boys, meaning around 5 tons to 9 tons or even 12 tons, huge boys. Spy satellites, again, like Hubble. So you had those sort of scenario where big things were used. So nowadays, because of development in electronics and efficiency, you can have surprisingly small solar panel that can provide surprisingly large amount of power for surprisingly large amount of things that can be done. So market is growing exponentially. Now there are two core requirements of this market, meaning market is asking two things out of you. First is cost, meaning it should be cheap. Now ISRO was doing very good in this market simply because ISRO was like, hey, we are launching PSLV. Now this is a big boy. It has an like majority of its horsepower consumed by like two major satellites, for example. And then you're like, okay, we'll do ride sharing with a lot of other small satellites, and then we're gonna achieve maximum cost efficiency, and the people who are doing ride sharing, they're gonna get cost effectiveness. That worked awesome, and it became a common thing. Even SpaceX does this. But here's the problem: this creates a problem of cadence, meaning you cannot launch it very quickly, meaning you have to book in advance and hope everything's go well, because every satellite launch provider will prioritize the main payload rather than stowaway, so to say. So these two things have to be met simultaneously. You cannot be like, hey, yeah, I'm gonna give you a very small, very cheap air ticket, yeah, you just have to book in 1 year advance. You're like, dude, no. So these two things are the core aspect of here. Now unfortunately, SSLV is designed with like old mindset, so it is very big, very heavy, and very, very expensive. Now why the heck it's big? Well, it's using solid booster. Now solid boosters are inherently less specific impulse compared to liquid system, inherently being bigger. However, it does have thrust benefit, and it is really awesome for ICBMs and missiles, not really good for satellite launching vehicles. And the primary reason why overall system of cost is too high is because solid boosters are armed from manufacture, meaning the moment manufacturer makes the casing and starts to pour grain in it, the end, it's armed device at that point in time, meaning every time 24/7 until it's used, somebody has to take care of it. And I mean seriously take care of it, meaning they are generally grounded, properly taken care of. There is like a serious safety code around it, where it's like you cannot smoke around it, of course, duh. Now you may like, aren't those explosives kind of safe? Well, yeah, they are safe, but do you really want to test it? That's the question of it. It's like, multi-layer redundancy. You want your powder to be safe. You want your staff working around it to be safe. You want precautions, stiff, you deployed there. That should be also safe. Then you have like, what, there's a very good chance it will work reliably. And safety is super serious, which seriously means it's going to cost a lot, because fundamentally every time somebody is around it, they are in danger, and they have to act seriously. They cannot be just like, hey, lol, man. No, it's serious. And consequence of that, like compared to, let's say, Astra system or Rocket Labs Electron Rocket, again, you can have a person next to it, nobody would care, simply because it's a liquid fueled system, meaning as long as there is no propellant in it, it's safe, inherently safe. Although technically Electron may not be safe because it does have battery, but given the fact that we drive electric cars, safe. This doesn't even have to worry about that. So fundamentally, liquids are far more preferable, and because of their higher energy density, far more preferable for rocket launches, not for missiles and ICBM, because again, they need to be on cold storage for a very long time. So fundamentally, the cost of this SSLV is not as low as market demands it. Is it lower than PSLV? Absolutely. Is it low enough where any college and university can just YOLO it? Not really. So the cost effectiveness is not as high as it needs to be competing with these two giants. And you might be like, isn't Astra about bankruptcy? Well, don't worry about it, because their tech is completely done. They only need a bit more polish. And I'm pretty sure any other company could buy them and then be like, we'll put some elbow grease to it, we'll finish it off, and then we're going to have a working setup. And not to mention, Electron Rocket is already working. So cost effective wise, rating is not good. Now, what about politics? Now, you have to understand, whenever you are talking about national agencies, you are talking about politics. So I'm hoping, this is my guess, hope, is that DRDO is guiding ISRO. And guiding means just telling you what to do. Now, why the heck that would be done? Simply for weapons development. Because you might be mindful, all missile systems are generally using same solid sort of system. Again, with minor changes, but they are same. You never want to test your ICBMs. You never want to test it, because the moment you test your ICBM, it's such a big event. Every satellite in the space can just, oh, that's your ICBM. That's how the launch plume is. That's how this works. That's how this works. That's how I'm going to track it. So that's why you never want to launch it. Now, same thing, it's kind of common in almost all space industry. That's why you will figure out like why the heck many governments have to, like especially governments that have been defeated. For example, Japan had to sign treaties where they like will not develop launch capabilities, simply because people know, dude, you are launching, that means you are building ICBM. So it's kind of common scenario. And for example, even in USA, space shuttle has solid boosters. Why? Why the heck you have solid boosters? I mean, like your last vehicle that went to moon had higher capability than this puppy. Why the heck it has solid booster? Because DARPA asked it nicely. So, and not to mention now it's become a headache because now this is being carried forward with SLS. So this is one thing. This is kind of common thing, especially with national engines, and I'm hoping for that because it does not make sense. Why would you use a goddamn solid booster system for a small satellite system? You want it to be cheap, but your total system weight is 120 tons. There are very few pads on this planet that can just like YOLO 120 tons. Yeah, they're big pads, but they have big cost. You want cheap cost, you make lighter pads. You cannot make light pads if your rocket's base weight is 120 tons, and that's all the time. So fundamentally, what does it amounts to? It amounts to poor philosophy. So basically, we are just burning money with extra steps. Not really good, and no real progress is made because I have been following ISRO. Again, ISRO has a good image to India simply because it has done some good things, and no denying that. However, in grand scheme of things, we know enough Indians know that it's not really doing as much as we want it to do for a country that has like 1.5 billion people and a like really strong economy. And I do not mean like pyramid scheme Chinese really good economy. So what the hell is happening? That's the whole point. The philosophy is poor and we are not making any progress. We are just repackaging old technology. It's like literally the documentation was like we have motors that are doing gimbling in solid booster. I'm like, that's ancient technology at this point in time. Genuinely ancient. I'm not even joking. Like genuinely ancient. Yeah, I'm pretty sure it must have been like double locked, patent secured. Not even patent secured. Like top secret for because it was used in ICBMs. But it's an old technology. It's not new. They're like you have BLDC actuators to move it around. Not new technology. So it's too little, too late. And private players have already beaten it. It's like, think of it this way. Now, like, this rocket is only 300 kilograms. 300 to 500 is not that far difference. And not to mention, most of the time you will be launching in those sort of range. And this rocket, this dude can be sitting next to it. No problem. He can be sleeping on the rocket. No problem. I dare you to do that with solid boosters. Again, don't do it even if you somehow find a mobile. And not to mention, it's cadence. This is the cadence. 2017, they launched one, boom. 2018, they launched around 4 times, success. 2019, success around 7 times. 2020, around 8 launches, one failure. 2021, one failure and around 7 launches. In 2022, this year, they have already launched around 7 satellites, 7 missions, and they're booked for around 13. So meaning they will be reaching a point where their average would be once per month. That is fast. I mean, like really, really fast. And they started with minimal money. Like their money counter was like exponentially smaller than what ISRO has. Like they are using gaming headsets. I'm not even joking. They actually have gaming headsets. It's cheaper. So that's the reality of it. It's like I genuinely like the idea that ISRO wants to, hey, this is a new market. Let's go into it. Let's make more money. Awesome. Why the heck your approach is the approach is wrong. Fundamentally, remove everything. It's just the philosophy behind it is wrong. It's not about corruption. It's not about competency. It's just like if you have wrong philosophy while you are working with something, you're gonna mess it up. You're gonna mess it up. There is no. It's almost like a pyramid scheme. So fundamentally, the politics side kind of makes me sad because realistically speaking, removing national pride out of it is just like it's here. It's already launching, and you built a system that can compete with this, and it's like 120 tons. Not really. So not really that happy with it. So this was my presentation on a small satellite launch vehicle. Hopefully you have liked it, learned from it. In that case, please click the like button, share it amongst your friends. That will help me a lot. If you didn't like it, didn't enjoy it, I urge you to press dislike, press it twice to show me extra disappointment. Please leave a comment because I do try to reply to all of them. Subscribe, press the bell icon if you're free. And as always, thanks for watching.